Hello everyone, welcome back to the Applied Physics lecture series. Myself Dr. Anantha Lakshmi, Assistant Professor in Physics from Department of Science and Humanities at MLR Institute of Technology. Today in this session, we are going to discuss about the de-broglie hypothesis. Firstly, let us go with our outline of the presentation. Today, we are going to discuss about the wave nature of light, next wave properties of light, problem of classical physics, de-broglie hypothesis, who proved de-broglie hypothesis, and the derivation of de-broglie equation. These are the things which we are going to discuss in this session. Next, wave nature of light. Light having both the wave nature and as well as the particle nature. Many experiments proved that light having both the wave nature and as well as the particle nature. From the diffraction and interference. From the diffraction and interference, it has proved that light having the wave nature, and the properties also noticed like frequency, wavelength, and as well as the speed. Next, from the experiment like photoelectric effect. From the experiment like photoelectric effect, it has proved that light having the particle nature. According to Einstein, light behaves like a photons. Light behaves like a photons, which are nothing but the energy packets. When these photons are incident on a metal surface, the emission of electrons takes place, which is the evidence of the particle nature of light. Hence, according to Einstein, all the electromagnetic waves behaves like a wave and particle depending on the type of experiment. Next, wave properties of light. For that, consider an example. Consider a wave. You can see here. Consider a wave. This the upper part, the maximum upward displacement from the mean position. The maximum upward displacement from the mean position is called crust. And this down part, that is the maximum downward displacement from the mean position, is called trough. Now, from this wave, we will study the different properties like wavelength and as well as the frequency and speed of light. Okay, what is wavelength? The length of consecutive crust and trough is called wavelength. The length of from here to here. The length of one complete crust, the consecutive crust and trough is called the wavelength lambda. Next, what is frequency? The number of waves produced in 1 second. The number of waves produced in 1 second is called frequency. Now, from these two, how can we find the speed of light wave? The speed of light wave is the product of wavelength and frequency, which is represented as C is equal to lambda into F. Please remember the equation. C is equal to lambda into F. Okay. These are discovered and these are explained by the Albert Einstein. Now, Next, move to the problem of classical physics. Okay, according to Einstein, he noticed the problem of classical physics. Let us see the problem, for which consider a particle like ball. Consider a particle like ball, and he noticed that a particle under motion, that is, particle is under moving or motion, it possesses some momentum. It possesses some momentum, that is P is equal to mv, where m is the mass and v is the speed. This he noticed under the classical physics. Similarly, when we try to find the momentum of light, well, you can say that the momentum of light is also P is equal to mv. But this is wrong. Why? Because the rest mass is 0. So here, what he did in his special theory of relativity, he observed that light behaves like a particle. And he has given a momentum that P is equal to h by lambda. Momentum P is equal to, this is the momentum of light. This is the momentum of light, where h is the Planck's constant. Whose value is 6.626 into 10 to the power of minus 34 joule second, and lambda is the wavelength of light. Next, moving to, our interest is to study de-broglie hypothesis. See, once again, recap the things what we did till now. According to the Einstein, light behaves like, that is, all electromagnetic waves behaves like both wave and as well as the particle. Now coming back to the de Broglie hypothesis. In the year 1924, Louis de Broglie has stated his statement in his PhD thesis. What he noticed that the particle-like electron behaves like both the wave and as well as the particle. The particle like an electron behaves like a particle and a wave depending upon the experiment, and wave depending upon the experiment. For this, he observed the motion of a ball, car and a balloon, and he noticed that all the three are behaving under both the particle and as well as the nature. Both behaving like a particle and a wave. Okay, but why don't we observe the wave motion? Wave motion of such bodies. Why don't we observe why we cannot observe the wave motion of such bodies? Because their wavelength is extremely small. That's why we cannot observe the wave motion of such particles. Okay. Now, according to him, the wavelength, speed and frequency of an electron. What is the statement? He said that the electron behaves like both the wave and as well as the particle. Now, when it behaves like a wave, then the wavelength, speed and frequency are connected with an equation C is equal to lambda F, which is the equation set by the Einstein. Next, when it behaves like a particle, it carries a momentum like P is equal to h by lambda. Momentum of an electron is same like the momentum of light. Momentum of light was discovered by Einstein. Here the momentum of electron is discovered by the Louis de Broglie. Okay, please remember these equations. C is equal to lambda f, which gives the wavelength equation, and P is equal to h by lambda, which tells us the momentum of the particle like an electron. Is it clear? Overall, Louis de Broglie stated that every particle in the universe can behave like a wave and or a particle. Can behave like a wave or can behave like a particle. Now, next, who proved this de Broglie hypothesis? In the year 1927, two famous scientists like Davison and Germer has performed an experiment by firing an electron. They fired an electron on a nickel target. And they have noticed that electron can diffract like a wave. And also observed that the wavelength of electron exactly matches with the de Broglie wavelength, and also observed that the wavelength of electron exactly matches with the de Broglie wavelength. For their experiment, Louis de Broglie has awarded with a Nobel Prize in the year 1929. For this experiment, Louis de Broglie has awarded a Nobel Prize in the year 1929. Okay. Next, the derivation of de Broglie equation. For this, he considered the Planck's quantum theory. From the Planck's quantum theory, he considered the energy of photon E is equal to h nu, which is represented by equation 1. Next, according to the Einstein mass energy relation, E is equal to mc square. Equation 2, E is equal to mc square, equating one and 2, we are going to get h nu is equal to mc square, where nu is equal to c by lambda. This implies h nu is equal to h into c by lambda. Then equation 3 becomes hc by lambda is equal to mc square. Okay. Then hc by mc square is equal to lambda. This implies lambda is equal to cc gets cancelled, h by mc is the de Broglie wavelength of light. Next, the de Broglie wavelength of a material particle is replace c by v. This implies lambda is equal to h by mv. Lambda is equal to h by mv. This implies lambda is equal to h by p. Okay, where p is equal to m into v. This is the de Broglie wavelength of a material particle. If capital E is the kinetic energy of a particle, that is E is equal to half mv square, then 2E is equal to mv square. Okay. Multiply and divide by m. Then we are going to get into mv square is equal to 2e. That is m square v square by m is equal to 2e. M square v square we can write it as p square. We can write it as p square is equal to 2me. Okay. Now P is equal to under root of 2me. This is the momentum in terms of kinetic energy. If E is the kinetic energy of a particle, then the momentum in terms of kinetic energy is capital P is equal to under root momentum P is equal to under root of 2me. Then the de Broglie wavelength lambda is equal to h by P, which is equal to h by under root 2me is the de Broglie wavelength in terms of energy. This is the de Broglie wavelength in terms of momentum. And this is the de Broglie wavelength in terms of energy. Okay, hence proof. In today's session, we discussed about the wave nature of light and wave properties we have discussed, which were explained by Einstein. We also discussed the de Broglie hypothesis, who derived the de Broglie hypothesis, and also the derivation in terms of derivation, that is wavelength, de Broglie wavelength in terms of momentum and de Broglie wavelength in terms of energy. Is it clear? Thank you.